Hi guys, welcome to today's tutorial. Today we'll be treating probability tree. I would like you to get your calculators ready with your writing materials. We'll be right back shortly. Welcome back. A number is selected at random from each of the sets 2, 3, 4, and 1, 3, 5. What is the probability that the sum of two numbers will be less than 7 but greater than 3? Alright, in solving this using a probability tree, we'll first of all have our first set of numbers 2, 3, and 4. Okay? Now, the probability of this first choice will be 1 over 3, 1 over 3, 1 over 3, since each of them have single outcomes. Okay? Now, including our second choice, this is 1, 3, and 5 for each of the set of outcomes 1, 3, and 5. Then 1, 3, and 5. Okay, now if we have this, the next thing we are going to look at is, since they said the sum, we'll look at addition of these two numbers. But first of all, this is 1 over 3, the outcome will be 1 over 3 and 1 over 3 for each and every one of them also. Alright, now this will be 2 and 1, 2 and 3, 2 and 5, 3 and 1, 3 and 3, 3 and 5, 4 and 1, 4 and 3, 4 and 5. Now the sum of this will give us 3, this will give us 5, this will give us 7, this will give us 4, this will give us 6, this will give us 8, this will give us 5, this will give us 7, and this will give us 9. Now, since you are looking for less than 7 but greater than 3, so we look at the probability of 5, 4, 6, and 5. So this will become 1 over 3 times 1 over 3 plus 1 over 3 times 1 over 3 for this, plus 1 over 3 times 1 over 3 for 6, plus 1 over 3 times 1 over 3 for this other one. So this will give us 1 over 9 plus 1 over 9 plus 1 over 9 plus 1 over 9, which at the end of the day, since our LCM is 9, this will become 9 all over 4 over 9 as our answer. So the probability of getting a number less than 7 but greater than 3 will be 4 over 9. And question 2 says, a coin is tossed 3 times. What is the probability of obtaining a head, same faces, and at least a head? Now, in solving this using a probability tree, it is important to know that our probability tree helps us to understand how to calculate multiple faces, okay, or multiple choices without making mistakes. And one secret about it is that in your sum of outcomes, they must always be equal to 1. I will try to explain that in this current question. Now, if you look at this, we have for a coin has a head and a tail. Okay, now this is our first choice. Okay, now the outcome here will be 1 over 2, 1 over 2. Now if we add 1 over 2 plus 1 over 2, it is going to give us 1. So that's what I mean by we should always ensure that our outcomes gives us 1 at the end of the day. Now for the second choice, we are having a head and a tail. For here, a head and the tail. This is our second choice. Now, since they say it was touched 3 times, that means we're looking at 3 choices. Now, the third choice, we are having a head and a tail. A head and a tail. A head and a tail. Then a head and a tail. Third choice. Alright, now for each of these outcome, we know that it's half for each of them. We know that it's half for each of them. Now, let's look at this. On this straight line, we have it as head, head, head. On this line, down here, we have it as head, head, tail. Okay, this way, head, tail, head. This way, head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head, and tail, tail, tail. Okay, now let's look at our question. It says obtaining one head. So out of this, where do we have one head? We have our one head here, and we have one head here. We have another one head here. Okay, so this will become, for our question A will become probability of head, tail, tail, plus probability of tail, head, tail, plus probability of tail, tail, head. Since we say they're asking for only one head. So now, probability of tail, head, tail, tail will be 1/2 times 1/2 times 1/2 plus 1/2 times 1/2 times 1/2 plus 1/2 times 1/2 times 1/2. So this becomes 1/8 plus 1/8 plus 1/8, which will give us 3/8. That's the probability of obtaining a head. Now, the next question is probability of obtaining same face. Same face will become probability of head, 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 since it wasn't specific, plus probability of tail, 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 which is 1/2 times 1/2 times 1/2 plus 1/2 times 1/2 times 1/2. Okay, which is going to give us 1/8 plus 1/8, which is 2/8. When broken down, will give us 1/4. All right, and the probability of getting at least a head. Number C, at least a head. At least means that the lowest number of heads, you can get more than one head. Okay, you can get more than one head, but the least you should get is one head. So we'll consider all these ticks except this one. Okay, so at least a head, okay, will become probability of all this, or we can do the probability of at least a head will be 1 minus probability of tail, tail, tail. Okay, so this will give us 1 minus probability of tail, 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 which is 1/8, will give us 7/8. So the probability of getting at least a head will be 7/8. Alright guys, we've come to the end of today's tutorials. If there be any questions or comments, please put it down in the comment section below and we'll surely attend to them. Don't forget to like, subscribe to our YouTube channel and also follow us on our Facebook. We still remain Mathematics Simplified.